Before we dive into Spring Boot itself, we need to understand two concepts that form the foundation of Spring: inversion of control and dependency injection. Neither of these is a Spring-specific invention. They are general design principles that Spring consistently implements. If you are interested in those general architectural concepts, I have a course on Udemy on exactly those fundamental concepts. This one is linked in the description. We'll start with inversion of control, or IoC for short. The name sounds a bit clunky at first, but the concept behind it is actually very intuitive once you compare it to non-IoC code. Let's assume you have a class called order service that is responsible for, processing orders. This service needs access to a database, which is provided by a class called order repository. In classic Java code, you would likely instantiate the repository directly within the service, that is, with new order repository, or perhaps in a static initializer. The order service decides for itself when the repository is created, which specific implementation is used, and how long it lives. The service has full control over its dependencies. Inversion of control now breaks with this approach, meaning this control is reversed. It is no longer the class itself that decides how its dependencies are created and managed. Instead, an external framework or a container takes care of that. The class relinquishes control and has what it needs provided from the outside. At first glance, this isn't earth-shattering. But think for a moment about what this means in practice. If the order service creates its own order repository, it is inextricably tied to a specific implementation of that repository. It knows exactly which class it is using. It knows how to initialize it. If you want to replace a repository with a dummy implementation in a test that doesn't require a real database, you have a problem, because the service constructs its own repository. And there is hardly any way to bypass that from the outside. With IoC, the situation is different. The order service now only specifies what it needs, for example, something that implements the order repository interface, and receives this dependency from the outside. The service has no idea what that actually is or which implementation is behind it, nor does it need to know. The container decides that. At a first glance, this might look like more work, and in a simple example with two classes, it even might is. The benefit becomes apparent as soon as an application grows, and to be honest, when you are using Spring or Spring Boot, you usually plan for an application that isn't a Hello World application. Imagine an application with dozens of services, all of which have dependencies on one another. If every class manages its own dependencies, a tightly interwoven web emerges that is difficult to test, difficult to maintain, and difficult to extend. Any change to a class can trigger subsequent changes in all places that directly instantiate that class. And this fictitious example here is just a very simple one, compared to an application doing something meaningful. With IoC and the container that handles the management, this web becomes significantly looser. Classes communicate via interfaces, here displayed in dark blue, with the implementation classes are highlighted in light blue. The container wires everything together at runtime, and the actual application code remains clean and focused on its business logic. So in Spring, this container is known as the application context. The application context is responsible for creating, configuring, and connecting objects. We'll take a detailed look at exactly what that means and how Spring does it in the next few lessons. But first, let's look at dependency injection, the specific mechanism through which IoC is implemented in Spring. So we'll see you right after a short break.